These are all, I think, yeah, every one of these is an old homework problem that you've done before. This is just an old homework problem. We're just doing them again. I'm just showing you which ones are most important. All right, newspaper posted this question. How often do you seek medical information online? So newspaper posted that. Of 1,972 internet users who chose to respond, 38% of them responded with frequently. What term is used to describe this type of survey in which the people surveyed consist of those who decided to respond? What's wrong? So, what term is used to describe this? Select all that apply. The respondents are a census? No. So what is a census? That's like everybody, right? That's like everybody in the nation or everybody, no. Population, again, that's everybody. No. Self-selected sample, yeah. Right? They chose to respond. You understand this was posted and people either chose to respond or not. Voluntary response sample? Yeah, that too. Basically, C and D are saying the same thing, aren't they? Yeah. What's wrong with that? So what? Okay, so they chose to respond. It's voluntary response. Do you remember when we talked about this?
So, but on the first one, is it one or two answers?
Select all that apply on that one. Yeah. Now, it won't be that way on the test. On the test, it'll just be one answer. It's just normal multiple choice, just one answer. Yeah. But there'll be none of the above there. Yeah, just for you, Eddie. All right. So what is this? What's wrong with this type of sampling? C, yeah, the responses may not reflect general population. Survey is loaded. No, that would be like if they put weird words in there. We don't know anything about their words. Many people will choose not to respond. Yeah, C and E, huh? Right, remember, that's the problem with voluntary response. You just get the extreme views, don't you? Most people don't even respond, so you don't really get the average view, you get the extreme view. It's bad statistics. It's just false information. It's not really the truth about what the general population thinks. All right, good, let's move on. Oh, yeah, gonna have to do it one at a time. So, sorry, it's going to slow us down. Where is it? Number 2? Yeah. All right. Determine whether the results appear to have statistical significance and also whether they have practical. Okay. Study of a gender selection method used to increase the likelihood of babies. Remember that? We were doing that a couple weeks ago? 1,966 users of the method gave birth to 967 boys, 999 girls. There's about a 24% chance of getting that many girls if the method had no effect. So they got this new whatever they're doing to try to get people to produce more girls, increase the likelihood of girls. And here's what happened. They got 999 girls, 967 boys. And there's a 24% chance of getting that if the method had no effect. Meaning, if the method was useless, and this was just luck, this could have just happened by random luck, and the method, the medical whatever, is doing nothing. Could be. What's the chance of that? 24%. Remember, that's what we're always going to be doing, especially in the future of this class, is saying, hey, yeah, the results look better for this new treatment or whatever, but how do we know it wasn't just luck? Maybe those patients were just going to do better anyway. How do we know it wasn't just luck? How do we know the new treatment is really making the difference? It wasn't just luck. That's called the p-value. We mentioned it briefly. We'll get into it seriously in the next few weeks. But that's what you're always looking at. And what percentage do you believe, how low does it have to be before you start thinking it's probably not luck? 5%. Yeah, so if it's 5%, that's typical in the world of science, is if something is a 5% or less chance of luck, you tend to not believe it was luck and really the treatment's working. So that's what we call statistically significant, if it's less than a 5% chance of luck. Okay, so here we go. 24% chance. Does that have the method, what are we supposed to say here? Has practical, does not have statistical. Yeah, that's it, huh? Does not have statistical significance. Because it's just, that 24% is too high. That could have been just luck. There's a quarter chance that was just luck. The fact that there were some more girls born than boys, there's a 25% chance that would have happened anyway. Right? So that's just too high of a chance. Could the treatment be working? Maybe, but there's not strong evidence, is what we're saying. How about number 2? What? Not many couples would likely use a procedure. Oh, yeah, not many couples would likely use a procedure that raises the likelihood of a girl from the approximately 50% rate to the what percent by this method? How'd you guys come up with that? Oh, no. Yeah, no, they mean 967 boys, right? 999 girls. What percent girls were born? What was the, because normally we'd think 50%, right? What percent in that group anyway, in that experiment where they had 967 boys born, 999 girls, what percentage girls did they get? How would you figure that out? How do you do percentage? Yeah, you got to add these up, right? Because percentage always means part of the whole, doesn't it? Like if I said, hey, I hope 20% of our class gets an A. So that would be the part of the whole. So you need to add those up. What is that? 1,966, huh? Yeah, because of one less. Oh, does it? Oh, yeah, I don't need to add them up. They already gave me that number.
Girls by that number?
Exactly. I didn't realize they'd already given me that. Exactly. Yeah, so then you just take girls over 1966. Yeah, just divide. Somebody got that?
51%.
51. So basically, that goes right here. 51%. So this method only raised the chance of having girls from 50 to 51%. So what does that mean? What's this last? So this method what? Has practical significance? Yeah, it does not have practical. So you get the difference then between statistical significance. There will be a question on the exam. I made it just today, I know. Between practical significance and statistical. I'll show you on Monday. Practical and statistical significance. Does that make sense? Statistical's the 5%. So the 5% is the... So you could have something that statistically has significance that doesn't have practical. How would that be? Well, what if they got a treatment and they proved that the chance of luck was only like 1%? So we're like, all right, this treatment's working. But if the treatment only made the chance of having girls go up by 1%, we'd say it's still not practically important. Even though, yeah, we believe that it's statistically, the method's doing it, it's just not doing much. So it's practically unimportant to us. See the difference there? So practical is practical. It's like, does that matter? 1%? No. That's just nothing. And statistical is the 5% on that. That good?
So, okay, so it's practical, it have to be like 70%?
Or something. I'll make it real obvious. It won't be a guessing. Yeah, it'll be real clear. Yeah.
So
Yeah.
50 to 51 is not practical?
Not practical. That's just such a small. I mean, people aren't going to spend thousands of dollars and do all the medical stuff. If you tell them, well, this will raise your chance of having a girl by 1%. People just are not going to do that, right? That's just not practical. So is that good? Does that make sense, that difference? So this will be on YouTube. I'll better move on. I want to get to the harder ones for you. So, where are we at? 1 and 2. Hopefully I can get that one. Yeah, there we go. 3, all right. Magazine, ran a survey, blah, blah, blah. That's the same thing. I'm going to move on from some of these, I think. I'm going to go to number 4 down there. What does it mean? Let's go to 4. What does it mean for the findings of a statistical analysis of data to be statistically significant? Yeah, so here's some words. Which of those is statistically significant?
A.
Yeah, exactly. You seeing that? So it is A. The likelihood of getting these results by chance is very small. Exactly. That's what statistically significant means. It's not luck. That's what's statistically significant. It's not luck. Practically means doesn't matter. You know, it only goes up by 1%. Who cares? But statistically means it wasn't luck. We really believe the treatment's doing it. Good. Let's go on to number 5. Whoops. See if I can find it. I'm going to have trouble seeing it on this thing, I think. There. Oh, I'm on 7. Whoops. if I can find 5. Maybe I'll just need to go on to that one. It's there. There's 6. All right, I'm going to move on with 6. A particular country has 40 total states. If the areas, what was it saying there? Oh, if the areas of 30 states are added and the sum is divided by 30, the result is a big number. Determine whether this result is a statistic or a parameter. So you can put on your 3x5 card the difference between a statistic and a parameter. What is the difference? Statistic, yeah, is from a sample. And a parameter from a population.
That would be A?
From a population.
No.
So remember, population's the whole thing. So that would be like if I said...
GP, isn't it? GPSS? Statistics, sample?
Yeah, it goes together. SS and P with P. Good way to remember it. Statistic goes with sample, S with S, and parameter with population. Exactly. So I'll make sure this is clear. If I said, what's the average age of all students at West Hills College Lemoore? There'd be some number, I don't know what it is, 21 or whatever. And then I said, you know what? I think I'll just find the average age in our class. That would be a statistic, because that's not the whole population. We're just a sample of the college, versus the average age for the whole college. That'd be a parameter for the whole population.
So that would be D.
Is that what it is? So I think it's D. The result is a statistics because it describes something from the sample. Exactly. Right? All they did is they took 30 of the 40 states. They didn't take them all.
If it would have been 40 of the 40, then it would be a parameter of the population.
Exactly. Is everybody seeing that? If you do them all, it's a parameter because you've got the whole population. If you only do part of them, they only did 30.
It would be a statistic, and then it would be a sample.
Because it's just a sample. A sample is just a little bit taken out. Like you sample the soup or something, right? You just take out a little bit. Or you eat the whole bowl, right? That would be the population, right? The whole. All right, let's keep moving. So number 7. Discrete or continuous? The weights of dogs in pounds at a dog show. Do you remember the difference between discrete and continuous? Discrete is discrete. How do I? I'm not very good. It'd be like continuous. Continuous is a clock that is smooth. Is that making any sense? Any number, no, nothing. Any number is possible. Discrete means only certain values. So there's 2 kinds of watches, right? There's watches that go second to second. You know, the second hand jumps from second to second to second. That would be discrete. Yeah, this little pin things. So discrete, it jumps. There's only specific values. I'm not saying this very well. Sorry.
Like whole numbers?
Yeah, it's not necessarily whole numbers. It's like a what, Brian? You have a good way to say it?
Discrete is countable. Continuous is not.
You're right. I don't know if they understand that. That's higher math talk. I'm not sure they understand that.
Because you have the weights of dogs at the dog show. That's countable. But,
Oh no, I think weights are.
No, that would be this.
Yeah, this one's
so
continuous.
what I'm trying to say is, discrete, you can count them. There's only a certain amount. How many?
Yeah, the
Things
clock
are
is the
between-
best way.
12 and 1. No, between 12 and 1, there is an infinite number of
Yeah, it's
places
continuous, really.
because it's smooth. It's not ticking like he said.
This
The ticks are countable. The
I'm
smooth is
confused.
not.
Right, you're losing all your things.
Yeah, Brian's right. I mean, this.
So continuous is infinite.
Yeah.
Very good.
Well, they can both be infinite.
Yeah.
I know. I feel like I'm just slipping around here. So the clock is the best way. Look at the clock. So there's 2 kinds, right? See, that clock is ticking from one. There is nothing between 1 second and the next. It can't be at 1.5 seconds up there, can it? It just jumps from 1 second to 2 seconds to 3 seconds. Right? Versus a smooth clock with a smooth second hand. Analog, they call it. An analog clock instead of digital. It's digital. It has certain digital spots. An analog clock, a smooth clock, can actually hit an uncountable infinite. I'm trying to get around the math word. An infinite number of spots.
So that's D.
Right? So that makes sense? So discrete is less. Discrete is specific spots. That's discrete. Continuous is a smooth clock. It's continuous. It's not jump, 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 jump. It's just continuously, always moving. All right, so which one is weight? Weight can be anything, can't it? Does a dog, if you say, my dog weighs 5 pounds, well, does it weigh really exactly 5 pounds? Maybe it's 4.93, but is it exactly that? Is it 4.9321? Is it exactly that? You see, we go through that. Really, weights are smooth. Real life weights are smooth. It's continuous. Yeah. The data are continuous right here because it can take on any value. Any value.
But then things like objects.
So it's like 1 second. If there's 3 apples.
Total number of objects would be this, right?
Yes, total number of, yeah, let's, right.
To make this make sense.
Right. So let's look down to number 8. Exactly. Let's look at number 8 there. It says, which of these are discrete? Look at number 8. So discrete is specific values, not any value. Hair color, tree height, amount of rainfall, number of suitcases on a plane. There you go. Exactly. You can't have 3.5 suitcases, right? You either got 3 or 4. That's discrete. All right. Good. It's really not that important, honestly. I mean, there might be one question. I can't remember if I put 1 or none on the exam with discrete and continuous. All right, where were we? No, I'm guessing at this little thing here. You know. So we're going to get into ways of researching. Do you remember this? Okay, so random, systematic, convenient, stratified, cluster sampling. A researcher selects every 871st. I wonder why they put a TH there. That's weird. Anyway, 871st, they should have said, Social Security number and surveys the person. What is it? That's a system. Exactly, that's a system. All right, let's go to number 10. In a poll conducted, 779 adults were called after their telephone numbers were randomly generated by a computer. Yeah, I mean, it's just random. It says it right in the thing, huh? Random. Good. 11. What are they doing here? To determine customer opinion on their safety features, Toyota randomly selects 40 dealerships and surveys all customers at those dealerships. So they grab 40 at random, and at those 40, they ask every customer in a certain way. That's a cluster. There is some randomness in it, but in the end, it's cluster. Remember what cluster is? That's where you just grab one group and go crazy on that group. Sometimes that's how companies survey. That's called cluster. Right? Because they just grabbed 40, but did all of those 40. All right, next, number 12. Market research partitioned all residents of a certain region into categories of unemployed, employed full-time, employed part-time. She is surveying 43 people from each category. That's stratified. Exactly. That's the way they really do polls these days. That's the state of the art in scientific polling. Stratified. That's what Gallup came up with. A magazine asked its readers to call in their opinion regarding the amount of advertising. Yeah, that's just a dumb way to survey, but that's a lot of what is done. Convenience. It's just what's easy for them, but they're not getting the truth that way. Blah, 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 some kind of time. This is the fast food times. Anyway, how many individuals, remember this homework problem, are included in the summary?
The frequency is, do you add those up?
Just add them up, exactly. They're just saying, hey, do you know you're supposed to add these up? Just add these up, whatever that total is. 50. Is that what it is, 50?
Yep.
All right, 50. So 50. Now, coming down here, is it possible to identify the exact value of all the original service times?
No.
That's no, because that's just categories, huh? Like, in other words, all we know is 4 times they were somewhere between 300 seconds and 359 seconds. We don't know exactly how much time. So no.
So D?
Yeah, it looks like D to me. Exactly. Good? Am I going too quick? I have all these answers on Canvas already. It's already out there for you.
They're different.
Different? Different from when you go in?
Yeah, like my quiz is not the same as yours.
Right. It'll be different numbers. The order will be the same, but it'll change the numbers. Yeah, it won't mix up the order. The order will be exactly the same for everybody, but yeah, it'll change the numbers. No, but what I'm saying is what I'm doing right now is exactly the same as what's on Canvas. Same answers everything, but yeah, it'll be different for each of you. So if you miss anything right now, if this literal one's on Canvas.
Can you talk about the one that you can download?
Yeah, from Canvas. Yeah.
PDF?
All right, so frequency table, these frequencies, how do we turn these into percentages? That's what they're basically asking, right?
Just to divide it by that.
Yeah.
By the total.
Just divided by the total, exactly. How many are there? 29,
42.
42. Quick adding there, Val. Yeah, 42.
4 divided by 42 and so forth?
Exactly. So this first one will be 4 divided by 42. What is it? 10.5%. Yeah, change it to, it's 0.105. Change it. Yeah, that'll be easy. 16. Now they want you to do cumulative. So that just means, okay, so like I think you'll understand if you just, as we see the words here, less than 40. How many days was the temperature less than 40? Yeah, just that one day, right? Can you guys see that graph okay? Yeah. Less than, so that's one day out of what? I don't know how many there are here. 6, 12, 22, 26, 29? I think there's 29 if you add those up. 29. So this first one would be 1 out of 29, whatever percentage that is. And the next one, less than 45. How many days was temperature less than 45?
You're not asking for percentage though,
We're
right?
asking for percentage.
Are you going by numbers?
Oh, you're right. They just want the one, huh?
So it's 1,
Good,
3,
thanks.
7.
Yeah, good. The next one is 3, because you add the 2 and the 1. Does everybody see that? That's what they mean by cumulative, because they want all of those less than 45. So they don't just want the next 2, the number 2, they want the 2 and the 1, because all those days were less than 45. You got it, right? That'll be easy for you. Fill those in. Okay, 19. So they're saying, basically you want to produce a dot plot. Do you remember, basically you're just putting dots on the graph for all these values. That's all a dot graph is. So could you answer this exactly the way it would look on the test on Monday? It'd be multiple choice, have some numbers. Can you put it on there? Yeah, you just got to be careful. I can't tell unless I look real close. I don't know. I'll start with A, for example. It's probably not A, but I'll just start with A. There's one dot. Where's that? 55?
Yeah.
Is there one number that's 55 in this list over here?
No.
There's no 55.
Lowest one's 50.
Lowest one's 50.
Oh, is that what it is? Okay, good. Lowest one's 50, so no way on A. B has a 50.
But it has 4,
C has a 50.
has 470s.
But D's out, huh? D's lowest is a 55. That's wrong. So it's either B or C, right? And what's next?
470s.
Does it? 1, 2, 3, 4. Yeah, 470s. Is that 4 dots?
I can't tell.
Yeah.
I know, you can't tell. Yeah, it looks like 4. You'll have to look close. Yeah, so it looks like it is B. Yeah, so just look close at the dots. Are there any outliers? Yeah, that 50 is, huh? Yeah, so that'll be easy. I'm going to move on. All right, so number 20, stem and leaf. They're basically saying take those data values, put them on a stem and leaf. So, this is like 67. This is like 72 and 75.
Okay.
Remember how those work? So, which one is right? You just got to be careful. I don't know. I can't tell. Looks like, okay, I'll just go 67. I'll just do one of the rows. Like, there should be a 67. This one has 66. No way. How many 70s should there be? Looks like 72 and 75. So this is good. This is no good. B's out. Yeah, so we're down to A or D. See what I'm doing? I'm just eliminating things.
8, 6, 8, 8, 8, 9, 8, 9,
886, 89, 89, 88, 6, 889,
D is the answer.
6899, I mean, huh? Yeah, that's it. It's D. Yep. Just be careful. And you can answer that other question. There should be a dot over 16, up 15 on the correct graph. Each one of these pairs of numbers should make a dot on the graph. Is that making sense? So 16, 15, over 16, up 15 should be a dot on the graph. Over 9, up 8, you know that next pair, should be a dot on the graph. Over 1, up 1 should be a dot on the graph. Over 13, up 12 should be a dot on the graph. Over 5, up 7. So you just got to carefully look at the graphs and find out which ones have those dots. Which one has 1, 1, for example? That'd be an easy one to find. Which graph has a dot over 1, up 1? Right there and right there. Both. So right now we're down to B and D just by finding the dot 1, 1.
What's for 1650?
They look pretty similar.
Wouldn't it be because you have 11, 11?
What? 2, 3.
Yeah, 2, 3. Good. I like that one too. Y'all seeing what we're doing here to help out with this? Right? So remember, these are just X, Y, X, Y, X, Y. Yeah, look at the 2, 3. So I'm just trying to find like really tiny or really big points that are easy to locate. Just to eliminate, because you see, I found the 1, 1 was only on B and D, right? See that dot right here? And well, that 1, I can't make it with this crazy thing. But see how the 1, 1 dot? Right? And now look at the 2, 3. There should be another dot at over 2, up 3. Which one looks like it's over 2, up 3?
D.
D. See, this second dot here is not, whoops, I missed it.
3.
Yeah, it's further over, huh? Is everybody okay with that?
The other way around.
So it's D. So just remember, on a scatter plot, that's X, Y, X, Y, X, Y. And just find the one that has those dots. That's all you'll need. There is a scatter plot question on the exam. Just remember X, Y, X, Y. So it's probability or percent chance of what?
It's luck.
Of luck. Exactly. It's always measuring the chance that it was just lucky that these patients are better. It wasn't really the treatment. So what do you think? 43% chance it could have just been luck. That's super high. It could have totally just been luck, right? That's very high. So there's not sufficient evidence to believe the treatment's really working.
And it's 5% or lower, right?
5% or lower is when we would consider significant evidence. Right. All right, number 23. Mean, median, mode, and mid-range. Yeah, so mean, median, mode, and mid-range. So how do we find mean? Do you remember? Want me to put that here? I can put that at the top of the problem. I would just put these in your calculator. This is on the test. Just put them in your calculator in the list. And the mean is X bar. Has the bar over it. That's the mean. We want to put that in your 3x5 card. Eddie will put it on his 4x6. That's for mean. Yeah, right. Everybody's got a 4x6, huh? And the median actually is also on that list. Remember the 5-number summary? It's the one in the middle. Remember the last 5 numbers? Remember when you go down those last 5 numbers that we just talked about, the 5-number, it's min, Q1, Q2, Q3, and max. Well, Q2 is median.
Question.
Halfway through, it's halftime. Yeah.
On these ones, are we looking for the median number as far as like in numerical order, correct? So we got to put the numbers in numerical order.
Your calculator will do it all for you. Yeah, if you don't have the calculator, you have to. Correct. Well said.
That's Q2.
Yeah, but if you just put these into your calculator will rearrange them and do the whole thing for you.
Off the list after we calculate it?
You just type them straight in, and it handles it. You don't have to worry about reordering them or doing anything. And when you get the 5 numbers at the very end, the one in the middle is the one in the middle. It's the median.
What symbol is that identified by on the calculator? Q2?
Does it say Q2?
No, it says mead.
Mead. M-E-D. Yeah, I think it does, huh? It says M-E-D.
Okay.
Median. Nice.
And the bottom 5?
Yeah, does it say M-E-D? Is that what it says?
Oh, cool.
Good. So it says MED. Let me write that up.
5 is, minimum.
Oh, okay, cool.
21.
MED. So just put them in. You don't have to read about. Now, if you're doing this by hand, yes, you would have to reorder those and get the one in the middle. You would have to do that. Yeah. Find the mode. Now, mode we'll do by hand. What's the mode?
The most
Yeah.
number, or?
Yeah, occurs the most, huh? Occurs the most. That's like shoe size or something. You know, that's an average for things like shoe size. So which number occurs the most up there? Is it? 218 twice. What about 220 though?
It can be both.
It can be both. Yeah. Is there anything else I'm missing? I think that's it. So yeah, so you just list them both. The modes are, and you would just list either order, 220, comma 218, either order, doesn't matter. Put a comma between them. So it says use a comma. And they're both it. Mid-range. What is mid-range?
Lowest plus the highest divided by 2? No, I'm thinking it's lowest.
I think you're right. Honestly, I can't remember. Honestly, you can tell by my expression, I'm not going to give you mid-range on the test. But it just kind of came in the package of this problem. So there it is. I don't remember what it is. Yeah, I think you might be right. Isn't it low plus high divided by 2? Is that what it
It
is?
says, yeah, high plus low divided by 2.
Good.
That's what Google said. I don't know.
That sounds, Google is always right. High plus low divided by 2. You know Google's a math thing, right?
Yeah.
You guys know that? You know what it is? What does Google mean? They've outgrown that. All right. It'll be worth our time for sure. Let's do the GPA calculation problem. So, 4 points. You know the system. 4 for A, 3 for B, 3
Yeah, that
for
one
C.
I hated that one.
Yeah, so let's make sure we're comfortable with this one. So, gets an A. So you can just write this whole example if you want. Right on your card.
Oh, man.
So, gets an A in a 3-credit class. So remember what you do is you write, how do you do it? You write
So we can write the question down and everything?
as much as you can fit on that 4x6 card.
Oh, I'm gonna.
So you write, how did I write it before? You write the points, times the credits, plus points. I just don't have room with this crazy pen thing. Times credits, etc. Dot, dot, dot. I'll have to put it off to the left. Does that make sense? You just keep multiplying points by credits, points by credits, points by credits, and add them all up. So let's do that. So that means A for 3 credits. What's an A worth?
4.
So that's 4 points times 3 credits plus. Good so far? A is 4 points, 3 credits. 4 times 3 plus. B, how much is a B worth?
3.
B is a 3.0, right? 3. B is 3 points. Whoops. B is 3 points. Times, how many credits was that? Each of 2 4-credit classes. So there's a 4 credit and another 4 credit.
3 times 8.
You could do that as well. Is that making sense so far? So I took A, so maybe if I wrote the letter above it would help. So this is because of an A, this is because of a B and another B, right? The A is worth 4 points times a 3-credit class. The B is worth 3 points times a 4-credit class. Another B, 3 points times another 4-credit class. What else do we have? A C in a 3-credit class. So a C is worth 1 point. No, 2. 2, huh? 2 for a C times a 1-credit class right here. No, 3 credit. What am I doing? 3-credit class. 3 credit. And then a D in a 2-credit. D is worth 1 times the 2 credit. You add all that up, and I'm running out of room here. Total divide, and then in the end, I'll just say divide by,
So the total divided by?
divided by, all right, total divided by. Sorry, I don't have room. Total divided by number of credits. Does that make sense there? So here that's not very good. Let me do it. So let me write it out better. So the GPA problem, you write 4, what was it? 4 times 3, 3 times 4, 3 times 4, so 4 times 3, 3 times 4, 3 times 4, plus 2 times 3, 1 times 2, 3, 1 times 2, all divided by the total units, total credits, which is 3 plus 4 plus 4 plus 3 plus 2.
So you just use the other numbers minus, like, I get it, not the numbers in parentheses.
Yeah, right, exactly. So total credits, right? On the bottom, I'm doing total credits. So whatever that comes out to be, 24, 36, 42. So 44 divided by 16, is that what it is?
46 divided by
13. Is it 46? 36, 42. I think it's 44 divided by 16. And then whatever that is. 2.75, or and however they want you to round it. It's just multiple choice on the test. 2.75. Does that make sense? You can put that right in your 3x5 card.
Now it does.
So this was the A, this was the B, the C, and the D, and then these were the total credits. All right, how we doing? Ooh, we're running short. Okay, so yeah, bank A, bank B. Let's just do bank A. Coefficient of variation. Coefficient of variation. How do we do coefficient of variation? Let me write it out for you one more time. Coefficient of variation, if you can read that scribbling, is, what is it? It's the standard deviation divided by x bar, which is the mean, change to a percent. Yeah, if you guys want to write times 100, that's okay. Just change to 100. Yeah, move it 2 places, multiply by 100. Yeah, it's standard deviation divided by x bar. So in other words, it's all in your calculator. So you would just take these numbers, put those into your calculator. Here, I'll do it real quick with you. Put those into your calculator. Oh, wait a minute, I got them in there. Oh, I just erased them. Crazy. I had them in there and I cleared them.
Too bad there's no back button.
I know it. Control Z. Okay, stat, calc, one var. All right, so I've got some numbers. Here's what I got. I got standard deviation, 0.507, and x bar, 7.17. You guys getting that? Divided by 7.17. So that comes out to be 0.07071. And then change it to a percentage. You know what to do, right? Goes 2 places. 7.071. I don't know how many places they want you to round. But there we go. So it's just x bar over the standard deviation, change to a percentage. You get standard deviation right off your calculator. Question?